Hi, today's video is going to be on inscribed angles. So we're going to look at all of the different relationships on how an angle can be inscribed. We've talked about central angles, and if you remember, central angles come from the center of the circle, and they are equal to their intercepted arcs. Now when I look here, I want to find the arc BW. So I want to look for this arc from here to here. Now if I had the central angle, which would be coming from the center, then the angle and the arc would be the same. Unfortunately, I don't have that central angle, but what I do have is this angle from M. Now M is an inscribed angle because it's coming from on the circle. So when I see this, the array that forms that angle from here to here is creating this intercepted arc. Now this angle is half of the arc measure. So if I'm given the angle, think about which one is bigger, which one's smaller. The angle is clearly a smaller measurement than the arc, so the arc is going to be bigger. It's going to be exactly double. The angle is half the arc, and the arc is double the angle. So if this angle is 33, we do 2 times 33, and that missing arc there, the measure of arc BW, is going to be 66 degrees. We go to number 2. I want to find the measure of angle NBC. So from N to B to C, I want to find this angle right here, and that's connected to this intercepted arc. That's the arc formed by those rays of that angle. This time I'm going from the arc to the angle, so I'm getting smaller. They are related. It is exactly half. So I take 63, I cut it in half, and we find the measure of angle NBC is 31.5 degrees. So the angle is half the arc. Just depends on what you're given. If you're given the angle, double it to find the arc. If you have the arc, cut it in half to find the angle. So we're going to apply this. Got a lot of stuff going on here. We pay attention to the fact that we are given the center of the circle is at E. That's really important because that center is going to tell us how our circle's related. And let's look at our inscribed angles. I see that this angle right here is 20. I follow those rays up to find that intercepted arc. So when I draw that ray and that ray, here's my intercepted arc. Remember, the arc is bigger than the angle, so I'm going to double the 20 to get to 40. And then when I look on the other side, here's the 40-degree angle. I look at the rays that create that angle to find its intercepted arc. And the intercepted arc, remember, is going to be double. It's bigger than the angle. So if this is 40, that means that this arc is 80. Now in this particular question, I want to find the measure of arc ABC. Remember, I see 3 letters. If I see 3 letters, I know it's going to be a major arc, which means it's more than half the circle. I have to hit those letters in that order. So from A, I want to find hitting B next and C last. So I'm trying to find this green arc. Now the good thing is I know that this part is 80. I found that from the inscribed angle. But this section is unknown. So I need to find out what this part of the arc is. If you remember earlier in a video, I said we often forget to use this idea when solving for angles. And that is from the center of the circle, I see a diameter here. BD, that chord BD, is actually a diameter because it's cutting my circle in half. And we know that half the circle is 180. So this entire half is 180. This section is 40. So if I do 180 minus 40, I can find that this part of the arc is going to be 140. So that major arc from A to B, AB is 140, and then BC plus 80 is going to give us 220. So that big arc, that major arc that we were looking for, the measure of arc ABC, is 220 degrees. All right, our next one we want to solve for x and y. So I start the same way. I see this 50-degree angle. I trace the rays that are forming that angle to find the intercepted arc. Here is the intercepted arc, and that's not bad. So that's what I'm solving for. I'm solving for y. So if this angle here is 50, the arc is twice as big. So I do 2 times 50 to find that this is going to be 100. So the first thing we just found, y is equal to 100 degrees, which is awesome. So now I want to find x. So I see that x is pointing to an angle measure. I look at the rays that create that angle measure, and I look at its intercepted arc. Do you notice something? Those two different angles are intercepting the same exact arc. So I have two different angles coming from two different spots, but the same intercepted arcs. They both are inscribed angles because they are both coming from on the circle. So here's another thought for you. If two angles, two inscribed angles, have the same intercepted arc, then those angles are going to be congruent. For the same thing, like if I know that this is 100 degrees, the angle is going to be half that, which is going to be 50. And we see that these two angles are going to be the same. So I know that 5x minus 30 is equal to 50. We add the 30 over. 5x is equal to 80. We divide by 5, and we find that x is going to be equal to 16. Okay, coming up on our last problem for this video. We want to solve for x and y. Now here we do have an inscribed angle. We have a lot of inscribed angles. More specifically, we have an inscribed quadrilateral. Quadrilateral because we have 1, 2, 3, 4 sides. When you have an inscribed quadrilateral, that means that all corners of the quadrilateral are touching the circle. We have a special relationship amongst the opposite angles. So the opposite angles are those angles that are across from each other. So x and 53 and 75 and y. You don't want to be confused because when we learned about parallelograms, we learned about a special property that opposite angles were congruent. That's not true here. Inscribed angles, their opposite angles are supplementary. So you may want to make a note of that to yourself. Inscribed angles and inscribed quadrilaterals have opposite angles that are supplementary. Remember, supplementary means that they add up to 180. So if I look at x and 53, those are opposite angles. If they are supplementary, they add up and equal 180. So I move that 53 over, and we find that x is going to be equal to 127. Our other opposite angles are that 75 and the y, so 75 plus y. Those have to also be supplementary. Those also have to add up to 180. We move the 75 over, and we find that y is going to be equal to 105 degrees. So remember, inscribed quadrilaterals, opposite angles are supplementary. All right, and we are finished for today.